Today's webinar, we're going to be looking at non-spatial applications using FME. And yeah, so just a little bit of background. My name is Martin Lufkin. I've been at OneSpatial for just over 3 years now, and I've been an FME user for more than 12 years. And I've got 20 years of experience prior to joining OneSpatial in the environmental data services sector, and there's a few FME certified badges there at the bottom there that I've gathered along the way, which is great. Just a little bit of a nod before we start towards OneSpatial. OneSpatial are a leading global partner of safe software and a reseller of FME. And since 1999, we've honed our technical expertise in the FME products, and our certified consultants help our customers who benefit from over 50 years worth of experience in the field of geographic information. We work closely with Safe Software to ensure that that you guys get the very best value out of your FME products. So today's webinar, we're going to be looking at perhaps an element of FME that is sometimes overlooked, and that is using it for non-spatial data tasks. Now, FME was primarily built for transforming and translating spatial data, but it's just as powerful when considering data that has no spatial element at all. And today, I'd like to take you through some applications and ideas that we've been playing with recently in FME. That FME can be really useful for. And these don't really involve any form of geometry of any kind. So let's begin with formats. As we know, FME supports hundreds of formats, and a lot of those formats are non-spatial. Reading in a text file or a CSV is quite easy, and creating and manipulating attributes in these formats are just the same as if you were doing this with a shapefile or a file geodatabase, for example. The beauty of FME is that once data is read into the workflow, it becomes format agnostic for the rest of that workflow. So all of the usual functions and transformers can be applied and used. So here we can see we're reading in a CSV, and we're using some fairly familiar transformers to us. We're using attribute managers, string concatenators. There's a test filter in there that's testing against one of the attributes. We've got creator in there as well. And then we're writing out, and writing's very similar. We can write out to a supported non-spatial format to either a web-based location or to a traditional file network or a local drive. And when reading non-spatial data, FME tries with some formats to find the geometry within that data. So for example, if you're reading in a CSV and it has perhaps an X and a Y column, you'll find that FME automatically assigns them a data type of X coordinate and Y coordinate. So let's have a quick look at that. So we've got our canvas here. We can go to our reader and select CSV. Let's just jump straight to our webinar data, and we can open that. And let's have a look in the parameters, and we can see there's an X and Y in this data in the CSV, and it's read those columns correctly. But a bit further down, if you've got it set to automatic attribute definition, you can see here the data types are already set to an X and Y coordinate. This also works for columns that are called easting and northing as well. FME automatically assigns those as well. And if this is the behavior you want, that's great. Just be sure to set the coordinate system correctly in the reader as well, or to add a coordinate system setter transformer. So we can go ahead and try this out. We're going to set that to the correct projection. We bring that data in. We can see we've got our data, and then we can run that. And in the visual preview, we should see our points that are automatically positioned on the map. So this is just reading in non-spatial data. FME is automatically assigning this based on the X and Y. Now, if this is behavior you don't want, and you're not interested in turning this into spatial data, then you can manually redefine the attributes and their data types within the reader. So let's try reading that in again. Go to our CSV, we can go to parameters, and if we don't want that, we can set this to manual, and we can select a string perhaps here, and a string here. It's also handy here to be able to read specific attributes if required, and maybe not read in other attributes as well. It's best practice to only read in what you need. So any attributes not required in the processing or the output can be unticked here and not read in. So let's untick value because we're not interested in in that attribute in this example. We don't need a projection because we're working with non-spatial data. So here's our CSV. You can see we've brought in X and Y, name, and not the attribute called value. And we can see there we've got that. And it doesn't pop up with a map window now because it's non-spatial data still. So if FME hasn't given your data a spatial element and you want it to, perhaps your columns aren't standard naming for coordinates. Maybe they're not X, Y, easting, northing. You can always use the vertex creator to create your points for your data. And then maybe you could go further and choose a line builder or an area builder to construct geometries beyond a single point. Again, just make sure that you've got your projection set correctly. But enough talk of making spatial data within a non-spatial data webinar. Let's move on to some ideas that we've been looking at more recently that don't involve a geometry at all. One of my favorite formats is a non-spatial one, and that's the directory and file path names reader. It's selectable as a format, and you give it a folder to read, and it will read and import the contents of that folder. I used to fiddle around trying to do this with DOS listings and various other methods, but FME makes this so much easier. So let's take a look. So if we jump into our workspace here, we can go to our reader and select the FMW, the directory and file path names format, and we can go in here. Let's just select pictures just for fun. And there's a number of different parameters we can use here. We have options to filter on a specific known set of formats. We can add in a star.png here if we just wanted to read PNGs, or maybe a doc or a docx file or whatever. We can recurse into subfolders. We can just pick out files or the directories if we want the folders or any of them. We can include or exclude hidden files, and there's a retrieve file properties setting as well. We're going to leave that to no in this case. We're going to open that up and see what that looks like. And here we have it. So as you can see, we're just going to run that, and we get back a list of all of the files within that folder itself. And we have some information about those files themselves. We've got a path to those files in both Windows and Linux form. We have the name and the file name of the file or folder. We have an extension, which is quite handy, and we also have some directory file paths which don't have the file name on the end in both Windows and Linux as well. We've also got path type on the end, which tells us whether it's a file or whether it's a directory. And this is great. And often this is all we need to start thinking about manipulating files without necessarily opening them. But let's try this again. Before we do, I just want to have a look. It's taken 0.2 seconds to run. Let's open up another one, same place, and let's tick the file properties box to yes, and see what we have here. So as you can see, we've got a few more options available to us. We've got all the standard stuff that we had before, but we also get things like the file size of that file, the owner of the file, and whether it's read-only or not, and a bunch of dates. So we have a created date, a modified date, and an access date. And these are really handy because now we can use them in our workflow to be able to filter out which files we're interested in. Just be aware though, setting this to yes will cause the reader to run slower than if it's off, because it's grabbing properties from the file, and it's going to take a little bit longer to do. So only really turn it on if you need these additional parameters. You can see as the log, it's taken 0.6. So it's not a great amount of time in terms of this kind of test that we've got, but it has taken 3 times longer. So if you can imagine, if it takes 5 minutes to read the, or 5 seconds, let's say, to read the first path, it's going to take 15 seconds to read it with the file properties. So just be aware that it's going to take time. So turn it off if you don't need it. So I find this really helpful, this format, not just as a monitoring tool, but also when you pair it with something like a file copy writer. It really comes into its own then. We can perhaps read a file and its location this way, work out when it was last accessed, and then move or copy the file into an archive area if it hasn't been touched for a period of time. It's also worth noting that this is all done without actually opening the files themselves in FME. And FME here can read any format, even if it's not a format it recognizes, because all it's dealing with is the files themselves. It's not actually opening them. So it's just moving files around. It's also handy when you want to use it with a feature reader. Perhaps you want to read in data of a known format, but only a selection of files from the folder. And this way you can read in file names and locations, perhaps use a tester or a test filter to specify which files to read, and then feed these into a feature reader to actually then read the files themselves. And in this example, we're reading in 107 images in this case. They're all different formats. They're PNGs, they're JPEGs, as you can see here, TIFFs, all kinds of stuff. And we've got a tester here to say the path modified date is of 2023. So we want to do something with the modified date of the files with a modified date of 2023. So we're going to filter those out. And this is without actually reading the files themselves. We're now down to 15, these 15 files we're interested in. And we're going to read those files. Now, it's a mixture of different formats here. So in our feature reader, we can select generic any format, and it will read those files in. And the data set we're using is path windows, which is one of the attributes that we're getting from our file and file names path reader. Just remember here to also merge your initiator and result. You want the attributes to continue and persist through your workflow, so that's very important. So set that to merge. And now we can see we can read in our 15 images, irrespective of format, and we've got them all here. Not such a useful window because they're all on top of each other, because they're not georeferenced. And we're going to resample these. We're going to take them down by 50% because they're all a bit too big in this example. And then we're going to write them out. We're going to write them out to a PNG file. And there's going to be one per image that we had before. So again, the root name is used from that directory and file paths reader right at the start. We're not going to create any world files or tab files, and we're just going to run that. So we resample and we write them out. And as you can see in our output images, we've got all of these PNGs. We've got 15 PNGs here that are all smaller in size than they were before. They've been resampled. They're of a standard format now. And perhaps you could use this. The resampler is very useful if your images are maybe too big. So you might want to read in the file properties, work out which files are too big, or the images that are too big to be able to be loaded somewhere or to be stored somewhere. You might want to resample them down and then rewrite them out somewhere else. Another non-spatial format that you might not be familiar with is the FME workspace reader. And this effectively reads all of the elements of one or many workspaces as different relational feature types. So whether you need to see which transformers need upgrading, or perhaps you're trying to understand how many connections are being output from each transformer and where they're going to, or maybe you're reviewing workspaces to identify the presence of bookmarks or annotations or workspace descriptions. This can all be understood and extracted using the FMW reader. So let's just jump into FME again and have a look at this. Again, we can go to our reader and we can select our FME workspace format, and we can go and find a workspace. Let's pick this one. There's not much in parameters, it's just a password if the file requires a password. And you can see here we've now got feature types. We've got a number of different feature types that are being read in by the FMW reader, and we can stick these here. You can see we've got all kinds of stuff going on here, and let's just run this to see what we get. Be aware this is not opening the workspace itself, this format. It's highlighting all of the elements within a workspace, so you can start to do analysis on your workspaces themselves. So as you can see, we've got 4 connections in this workspace that are connecting between transformers. We've got file properties, we've got creation date, last run, whether it's password protected, some statistics around number of breakpoints, number of readers, number of writers. Quite a useful bit of information is number of out-of-date transformers. So this highlights that there's a couple of transformers that may need upgrading if you so wish. We've also got a list of transformers here and what they are and what version they're on, whether it's enabled, and what the build number is of the transformer. We've also got some workspace properties, so the build number of the actual workspace itself, the last save date, and any workspace descriptions, categories, anything that the author has put onto the workspace. So this is really handy, and a good example of this would be something like this. So we've got this example where we have a feature reader, and feature readers work in the same way as traditional readers. We've got all of the same formats available to us in a feature reader. So this feature reader here is formatted to read an FMW file, but it's only reading the transformers, connections, and reader feature types. There's only 3 feature types we're needing here. And essentially this workspace is just trying to find all of the readers and feature readers with no outgoing connection. So we're testing on the transformers to say, are you a feature reader? Yes, feed it through to the feature joiner. And the joiner is joining against those connections and trying to find any that don't have any connections, which is the unjoined left. And the same below on the bottom half, it's reading in the reader feature types, because these readers aren't transformers. So you have to go a slightly different route when you're looking at traditional readers and looking at no outgoing connection. And the beauty here is that all of those feature types within an FMW reader are all relational. So there's an ID linking everything to everything else. So if the connection will have a similar ID or a linking ID to the transformer ID. So everything can then be linked through together. Another idea that we've been working on is creating scripts within FME. Predominantly SQL scripts, but this concept could be applied to anything really. And this involves having a fixed set of information like a template, so a text file or something similar, and joining that together with some kind of dynamic data that we can stitch together in such a way that we can create a dynamic script that can then be used for maybe a data release, if this is what our friendly DBAs require. So here's an example of just this. So let's say that we need to create a script to apply spatial indexes to 100 tables. Now, we wouldn't want to do this by hand, and we wouldn't want to go copy and paste all the way through and edit those scripts. So we're going to get FME to help us. So let's read in our 100 tables. So this is just reading in 100 CSVs, all with a table name, and the attribute manager is just changing the name of that. Here we go, it's running. It's just changing the name of that table name to table underscore and then a number, just to give us a good example. So as you can see here, we've got table name, fairly happy with that. And they're the tables we want to update with a spatial index. Now, we can use this to read in, use these 100 features that we just created to read in a template SQL script. Now, we have a SQL script here. It's very simple. Create spatial index. It's got a bunch of these percentages. Create the index schema name dot bunch of percentages geom index on. Fairly standard SQL script there. But that's our template. We want to read that in 100 times. So we're going to read that in and use those 100 initiators to read it in. You can see now we've got 400 lines because that template had 4 lines in itself. So we're just taking that and duplicating it. And you can see here we've got a text line, and it's duplicated all the way through for every table that we have. And what we're going to do is we're going to replace firstly the schema. So that schema part. So we're going to use that as a wildcard. I'm going to replace that with schema underscore 1. And another way we could apply that is to use this wildcard. And having wildcards in the template, just be aware that you might want to pick something that's not going to ever be used within your SQL script. And in this case, we're replacing those 7 percentages with a table name, which is an attribute. And we can run that. And then we're going to write that out to some text line data. Now, we could use a text file writer here, but I'm going to be using a CSV writer. And we're going to be just writing that one attribute out and calling it spatial index output. The reason I'm using a CSV is because in our parameters, we can set the extension to SQL. So instead of us having to go in and then manually change that to be a SQL script, we can actually write it out as a SQL file itself. So we can run that, and that's pretty quick. And that's finished. And here we have it. So we've now written our SQL script, duplicated it a number of times, changed the table names, and giving it a little bit of a comment at the start. And we're quite happy to pass that on to our DBA, and it's lightning quick. It's lightning quick. And obviously this is a fairly straightforward example, but using different wildcards and differing attributes, we can build fairly substantial scripts using this method, and it's lightning quick. It really is. So we've looked at essentially creating non-spatial data in these examples, and like I say, we can treat non-spatial data like any other data in terms of transformations and translations. But what if our non-spatial data is in SharePoint or Dropbox and not a traditional file location? Well, FME has the answer. There are loads of designated connector transformers that can access online cloud repositories. Setting these up using web connections and adding these to your canvas is fairly straightforward. You may need further permissions to access certain repositories, so having IT on hand is useful if you're going down this route. But here on the right-hand side, we can see we've got a Google Drive connector. And the beauty here is that we can see there's different download options available to us. We can download as a file or a folder or as an attribute. And an attribute appends the file to an attribute to the initiating data. And this is really handy if, for example, you're downloading maybe a very large image and you don't want to save it anywhere before manipulating it, or you want to do some transforming of whatever file you're downloading before then writing it out. And there's a number of different connectors you can connect to here. So finally, I'd like to leave you with a challenge. Now, we all associate FME with our traditional data management tasks. But have you considered it for your organization's finance data management, for example? What about working with Outlook calendars and setting up emailers to let others know about key events? How about using it as a bulk emailing tool to read lists of emails and sending out marketing literature to those emails? FME can be as wide-ranging as you want it to be with whatever data you can throw at it, be it spatial or non-spatial. And I'd encourage you not to limit the power of FME to just our data teams. It's a tool that can sit just as comfortably in any team in your organization. Thank you.